Good morning. My name is Rupak Kumar. I am in IT department. Today we are going to know the DBMS important topic, one of the important topic from database management system. In this we start the scheduling. Scheduling is the one of the important topic from database management system. First is what is scheduling? So if we come to know the process, what is the transactions we do in a daily life, so it must be in a schedule. So for if we talk about the definitions of schedule, so schedule is defined as a execution sequence of transactions, means when any executions is concerned with the database, means there is number of transactions is there. So we do transaction number 1, 2, 3, 4 and another transaction there. These all transactions must be scheduled. Okay, and this is scheduled when we have a transaction manager who schedule these transactions. These transactions, all the transactions in a DBMS must be scheduled with the help of this transaction manager. Transaction manager manage the transactions and make it in a schedule. Okay, which transaction perform first, which is second, which is third. So this is what we can say if we talk about the definitions. So a schedule is defined as a execution sequence of a transactions. How this transaction executed, what is the sequence of execution of these transactions, this is what we call the schedule. So schedule is nothing, it's basically a execution sequence of transactions. So next, who manage this? This is managed by the transaction manager. They schedules all these transactions in a process. So we can say a series of operations from one transaction to another transactions. It is a series transaction. If we talk about if it is not in series, then we can say these transactions must be a parallel transaction. Parallel means the transactions 1, transaction 2, if there is some schedule S, then we have a transaction T1 and T2 in the same schedule. Okay, this is what the how these transactions is in this schedule. Suppose T1 is transactions and T2 is, so we can say this is what the parallel. This is what the, if there is T3, there is some T4, then we can say it is in series, one after another. So this is what parallel and series transaction. So series operations from one transactions to another, one to another. This is what in a series, and otherwise it must be in a parallel. This is occurs in a parallel, and this is managed with the help of who manage all this. This is managed by the transaction manager in a database. Who manage this? This is managed by the transaction manager. So next is that it is used to preserve the order of operation in each of the individual transactions. Means if there is several transactions, that it preserves the order of operations. What is the order of operations? Which transaction operate first, then other transaction T1 operate first, then T2 operate first. This is what scheduled with the help of this transaction manager, you can say. Next is your schedules in a DBMS. This is what the flow chart we can say of schedule. We first overview of this all this schedulings, how it's look like, how we go further with this schedulings. So this is what first we have a schedules in DBMS. Schedules is basically divided into two types or two categories of schedules is there in a DBMS. One is your serial schedule. We're just talking about that. One after another is serial schedule. Then schedule is divided into two, serial and non-serial schedule. Then we have a further, in serial there is no any further division. Serial means serial, nothing else. And if we talk about non-serial schedule, means then we can say non-serial schedule is further divided into two types. One is your serializable and another is your non-serializable. Serializable schedule means the schedule in a serial manners, and non-serializable means it is not in serial. We discuss it further, but we have only the flow chart how the schedules is divided. Schedule is divided into two: serial schedules and non-serial schedules. There is no division of serial schedules. Then we have a non-serial schedules. Non-serial schedule is further divided into two types: either it is a serializable or it is a non-serializable. So two types of non-serial schedule. If it is serial, then no problem, and if there is a non-serial, then there must be categories. That category is serializable and non-serializable. Further, if we talk about the serializable schedule, we have a conflict serializables and view serializables. Means in serializability, their types is conflict and view. Further, it is divided into two: conflict serializable and view serializable. And if we talk about non-serial, then non-serial is further divided into two category. One, if it is non-serial, it may be recover or not. So this is what they thus divided into two category. It is recoverable schedules and non-recoverable schedule. Non-serializable is recoverable or maybe not recover. We can recover that and either recover or not recover. So it is further divided into two category. If it is non-recoverable, means we cannot recover. Or if we can't recover, so there is no any division. It is only that is it may be recover or not, yes or not. So there is two. It is recoverable and non. Non means no any category. And if we talk about recoverable schedules, then recoverable schedule must be three types: cascading schedule, cascadeless schedules, and strict schedule. Means if we are going to recover our schedulings, then we have further divided into three types. By three way we can just recover the schedule. So this recovery schedule means the cascading. How we recover? With the help of this cascading schedule, or we can say cascadeless schedule, or we have a strict schedule. Cascading, cascadeless, and strict schedule. Further, recoverability is divided into three categories. This is for the flow chart. This is what the scenario. We just go through from this scheduling to this flow. In this part, we must cover up to, I think, non-serializable or view serializable. Then in another part of this video, we just cover the rest part. So this is what the important flow chart. You must have a scenario in a mind that how the serializability is processed in a DBMS. Serial, non-serial, non-serial serializables, non-serializables, conflict, view. Then again, non-serializable is recoverable and non-recoverable, cascading, cascadeless, and strict. Clear? Next, we have a serial schedule. So now we talk about the serializability of these schedules. What is serial schedule? As we know, as it is said that serial means one after another. One after another means a schedule is defined as an execution sequence of transactions. Means one transactions, then another transactions, then again another transaction. How the transactions is take place in a some scheduling, some process. One transaction is processed, another is then another. So we can say this is what how executions is occur. Now serial schedules, in a serial, one transaction is executed completely before starting of another transaction. Means when it is in serial, means one transaction come in a process, they complete, then another transaction again come in a process, then they complete. So this is what if we define a serial schedules, then in a serial schedule, one transaction is executed completely before starting of another transactions. Next, we can say how we just take a real life examples of this serial schedule. Anything in a serial manner, one after another. If we are waiting in front of vending machine, we can have in a row. We must have in a row because they just complete the one person in front of the machine. They just complete all the transactions and then another person's come in row. Means one transaction is completed, then another transaction is started. So this is what the one after another process. So we can have a real life examples of ATM machine given here. ATM machine is also one of the examples of this serial schedule. Okay, so when one transaction execute, no other transaction is allowed to execute. Means if someone is in front of ATM machine, are you allowed to go further? No. So no one is allowed. When they complete their complete transactions, then only another is allowed. So this is what the serial of the things, seriality of the things. So when one transaction execute, no other allowed to execute. Means all are in a waiting process. And this is managed by the schedule manager. Next, this type of execution transactions is also known as non-interleaved execution. Means they are not interconnected. They are not connected with each other. Means one person in front of ATM machine complete this transaction and they both are not related with each other. They are complete interleaved. Clear? So here we see there are two examples of serial schedule. Serial means transactions one take a first transaction, that is what read operations on A. There is A and B, two types of schedule is there. One is A, another is B. So in this transaction T1, first read operation perform on A data, then write operation perform on A data in the same transaction, then again read operation perform on B data. Next write operation perform on B and then commit. After completing these T1 transactions, it may be several time read, several time write and anything else. When it completed completely, when it completed the transaction T1 completed, and when it commit final, then only the another transactions of this schedule is started. That is what transaction T2 after commit they start. That is what they start the any operations on any data item. That is what it may be an A or B. It start first reading of A, then writing of B. It may be there may be a several transactions over there. So then they commit and this is complete. So this example is fully serial schedule. There is no any parallelism. Means there is no anything in a parallel is running. T1 is completed, then T2 is started. Again, then we can again it may be T1 started, then T1 start, T2 started. So there is nothing like that to means parallelisms in this. This is one of the examples of fully serial schedule. Okay, so this is what there is no any parallel things over there. Nothing is parallel. No? After committed, the T2 transaction start, and after this complete, it may be there must be some transaction in a T1. So there is no any parallel things over there. Clear? So this is like to in examples 2. In examples 2, we have a transaction T1 and T2. In this example 2, first transaction 2 started reading of data item A. Then again they just perform the operations of writing on data item B. Reading, writing, and then they committed. Clear? So first in this example 2, T2 start the transaction. So there is no any transactions in the T1 section. If there are any transaction in this T1 section, then it is not a serial schedule. So this is one of the example of serial schedule. Then T1 start reading of on item A, writing on A, reading of B, writing of B, then commit. After commit, it may be the transaction 2 start again reading and writing of the operations. It may read of A, again it may write something on B, anything else. Then at that time there is no any transaction in this transaction T1. So this is what a serial schedules in a database. Clear? We can take many real-time examples. We are standing on the vending machine, in front of vending machine. We are taking a movie ticket. We are just in front of ATM machine. So there is many serial schedules examples of our daily life. what is the property? If you talk about the property of the serial schedules, so we have a 4 property. It is consistent. Serial schedule always consistency shows. It is recoverable. We can recover this serial schedule. If any transaction fail, anything unwanted occur, then we must have a recovery of this. Next is your cascadeless. It is a cascadeless. Always. Serial schedule is always cascadeless. Next we have a strict. It is a type of one of the type of strict schedules. Clear? So this is what serial schedule. Clear? Now next we have a, we just now come to the next, that is what scheduling of, that is what serial and non-serial. Serial and non-serial. So we complete the serial schedules. Now we have a non-serial schedules. Now come to the non-serial schedule. What is non-serial schedule? Means when the multiple transactions is interleaved one after another. T1 is doing something before committed T2 start, before committed T1 start. Then there is no any interleave. They are interleaved. There is no any seriality one after another. Then it is called as non-serial schedule. If we just say the definition, this is a type of schedules where the operations or operations of multiple transactions, transaction T1, T2, T3 are interleaved. Means transaction T1 is just running, in between there is a transaction T2 is also doing some operations on same data items. So this is what the we can say non-serial. So there is no any serial things is there like that serial schedules. So next point we can say operations of all transactions are interleaved or mixed with each other. They are just mixing one after another. The transaction is mixed up. One is doing reading operation, another is doing writing operation, then again reading, writing. It may be a interleave between the transactions. This might lead to a rise in concurrency. What is the problem arise when there is a non-seriality? It must be a there must be a concurrency. Means always it is always show the concurrency problems in a DBMS. So non-serial schedules, it might lead to be a concurrency problem. Now further, as we know, it is divided into two categories. That is what non-serial is divided into serializable and non-serializable. Serializable schedules and non-serializable schedules. Serializable schedules and non-serializable schedules. Clear? So here we see the transactions. There is two transactions in this example. One schedule. One is doing transaction 1 is doing reading operations on data item A. Same transaction is doing writing operations on data item B. We talk about two data item over here, A and B. Then transaction in between, after writing of B, then transaction 2 start reading of item A. Then again it start the reading of item B. It start reading on item B. Again it start writing on item B. Then it commits. Means when they are before commit of this transaction T1, the transaction T2 in parallel also started. So there is no any serial things over there. This is a non-serial types of transactions. This is a non-serial types of transactions. Clear? So this is what examples of non-serial. If we take an examples, so we can have a many examples of non-serial schedules. Means if we are accessing any website, any bank website, so there is no any seriality over there. I am also accessing the same sbi.com. You are also accessing the same site sbi.com. Some another person is also accessing. Means at a time several transactions is started in a same site. So this is, there is no any serial things. It is a parallel. It is a parallel process. So this is what the real examples. Now if we talk about properties, that it is not always in that we have in serial schedule. In serial schedule we have a consistent, recoverable, cascadeless and strict, but in this we have a not always consistent, not always recoverable, not always cascadeless and not always strict. So there is not always consistency, recoverability, cascadeless or strict in the non-serial schedule. This is what the basic of your non-serial schedule. Clear? Now, what is difference between serial and non-serial schedule? Basically, serial schedules and non-serial schedule, all transactions executed one after another. In a serial and in a non-serial, all transactions executed simultaneously. They just work simultaneously. If we talk about the serial, then we have a no concurrency allowed, and in this we have a concurrency allowed. Less resource utilized and CPU resources is less and CPU throughput is also less. But in a if we talk about non-serial, improve resources utilization and CPU, because if there is any time gap between that, the another schedule is affected. Next is your less efficiency, more efficient, no further type, and it is two types. Example is this. This is what the difference between serial and non-serial. So thank you for this part. So we'll continue in the next part by tomorrow. Okay, thank you all of you.